Welcome to the first part of our series on chemical nomenclature, and today we're going to talk about ionic compounds and how to name these. So whenever we think of ionic compounds, we should be thinking that in most cases these are going to be some kind of metal plus a non-metal. Or sometimes we think about it as a cation plus an anion, where the anion or the cation may be some kind of polyatomic ion. So in naming the ionic compounds, what we really have to do is first start with the cations. Whenever we name the cations, the first rule is that a cation from a metal, is really just equal to the same name. So if we think about sodium ion, we still call it the sodium ion when we name the cation in an ionic compound. These are monoatomic ions, and we just name them the same as their name. Second rule is cations from metals with more than one possible charge state. Well, these are usually some kind of transition metals or transition element. And in that case, we use a Roman numeral to denote that charge. So we could think about iron 3+. Iron 3+, we would call iron, and then we'd put a 3 in Roman numerals in parentheses, and this makes it the iron 3 ion. Alternatively, we could have the iron 2+, which means that we call this the iron 2 ion. Again, we have the 2 in Roman numerals after the word iron. But there's also another nomenclature for it where we can add the ending OUS for the lower charge species and IC for the higher charge. So here Fe2+ has a lower charge, so we call it the ferrous ion, whereas Fe3+, which has the higher charge, is ferric ion. Third, cations from nonmetals end in ium. Well, there's really two that you'll encounter. One of those is ammonium ion, NH4+, and the second is hydronium ion, which is H3O+. Now, in most of these cases, we just have to memorize these names along with their polyatomic ion. So that's the cations. The cations are fairly easy in naming. The second part is we need to name the nonmetal or the polyatomic anion in this case. Again, monoatomic ions are just use the ending IDE. So all we do is change one of these elements from maybe chlorine. We drop the INE ending and we make it chloride. That tells us it is the ion. So we say it's the chloride ion or the bromide ion. There are some of these polyatomic ions that also use the IDE ending. These are hydroxide, OH-. We have cyanide, which is CN-, and we have peroxide, which is O2, 2-. Most polyatomic ions contain oxygen. The oxyanions are either have some kind of ending of ate or ite. Usually the species with more oxygen has the ending ate, and the species with less is then called ite. But these can become a little more confusing because some of these polyatomic anions contain oxygen with more than 2 members in the series. And so those have the following nomenclature. Now you can memorize it this way, or alternatively, you could just go ahead and remember the family of oxyions. And the one that I put in blue are the ones that are most common. In my classes, I require you to memorize the ones that are in blue. Now you can see that we have carbonate, which is CO3, 2-. We have nitrogen, which we have nitrate or nitrite. Again, the one with more oxygens has the ending ATE, and the one with less has ITE. We have phosphate, we have sulfate and sulfite. And what I want you to notice is it's just which one has more or less oxygens between these two. Because here we have the ATE ending, even though we have SO4. We have sulfite, the ITE ending, even though we have 3 oxygens. But you'll notice when we had 3 oxygens with the nitrogen, it was nitrate. So it just depended on what's in this little box, as if we had the ATE or the ITE ending. Same thing, we turn to sulfurs. And then we have this group of halogens, which all have pretty similar nomenclature. You'll notice that with 4 oxygens, we have perchlorate, 3 oxygens chlorate, 2 oxygens chlorite, and 1 oxygen hypochlorite, which is similar to that bottom part of the last slide. Alternatively, lastly, we have the polyatomic anions that contain oxygen, but they also have additional hydrogens. And we name these by adding the word either hydrogen or we add bi, okay, for a single hydrogen. We then have dihydrogen for 2, trihydrogen, and so forth. So in this case, we have the carbonate anion. And if we add hydrogen to it, if we add just a single hydrogen to that, where we get HCO3 minus, for every hydrogen we add, we remove one negative charge, we would now name this as hydrogen carbonate anion. Or alternatively, you could just call it the bicarbonate anion. Same thing we look at phosphate ion. Phosphate ion is PO43 minus. We could add 2 hydrogens to it, removing 2 negative charges, and we could rename this as dihydrogen, because we have 2, phosphate anion. The last part of naming ionic compounds really just comes from combining the name of the cation and the anion. So calcium was the calcium ion, so we have calcium. Chlorine, we now change the ending to chloride, and we call this calcium chloride. We also see this with potassium perchlorate. We have the potassium ion, and we have the perchlorate anion. We combine those names to make potassium perchlorate. That completes how to name ionic compounds.